Hello everyone, welcome back to my channel. Today let's go over a medium question that I finally solved on my own after a lot of trial and error, so I'm really happy about this. Again, it did take me quite a while, but I did come up with my own solution at the end. So let's go over it. This one's called Unique Length-3 Palindromic Subsequences. So basically you're given a string S, you want to return an integer of how many unique palindromes of length 3 are a subsequence of S. Basically what that means is a palindrome is the same forward as backwards, and the fact that it's length 3 makes this a lot easier. So ABA, ACA, ADA, AEA, all the way to Z are all palindromes because same forward as backwards. So we want to find how many length 3 exists as subsequences, meaning that, for example, if you have this string right here, if you're on A, you want to find either A and A, or either A, B, and A, or A, C, and A as well. So the same or different in same. That's what a palindrome is. If you try this with BAB, same thing, same, and then different, and then same, or BBB, the same throughout the whole thing. So the fact that there are 26 letters is going to help us immensely here, because first of all, I came up with an n-squared solution, which I'm going to show you, but it didn't work, and then I optimized it and it did. So let's come up with the brute force way to do this, which is just to iterate over S from left to right and ask, so for J and range, so basically what we want to do is, the brute force solution is a little messy, so I'm not going to show it to you, but basically what we want to do is we want to keep track of the characters here and their index locations, right? Because B has to appear before another A if we're currently looking at the current A for it to be valid. It can't be AAB because AAB is not a valid palindrome from forwards to backwards, right? So let's go ahead and iterate over S. And what we're going to do is have a set called scene, because we want to keep track of how many unique palindromes. We can't count the same palindrome twice. AAA can't be counted twice in the result. So we're just going to return the length of this set at the end. And then right now what we're going to do is we're going to keep track of every character and where it appears. So ODV, the character itself, dot append I, that's the location. And this is going to help us because as we iterate over S, so what are we going to do? Well, we only need this now. We're going to reflect every character and where it appears by removing the current character from OD. So ODV, ODS of I, which is a current character, dot remove I. If OD of S of I is empty, that means that character doesn't appear anymore. For example, if we're here, if we're on this character with this 20 loop and then B doesn't appear, so we have to delete it. If not ODS of I, if the length of that list, if we have B and then we have this, then just delete the whole pair because it's not there anymore from the current to the right, then the string. So delete ODS of I. And to confirm this, we can print S of I and we can also print OD. So now, as you can see, we're here, but A also appears at index 1 and index 4, right? B appears at index 2, C appears at index 3. So what that allows us to do is basically say, okay, so for the keys in our dictionary, because there are only 26 letters, so these are going to be unique, instead of having to loop through a bunch of times for every single duplicate character, which was my time complexity issue initially. But for each key, each letter, so we're going to ask so for example, if we're currently on A and we see a B, right? So if K is not equal to the current character, right? So B is not equal to the current A, that's fine. And then now we can say if there's some kind of, so basically as long as there's something in here that's less than something in here, then we know that there's an A that appears after that as well, which means we can just add ABA to the result once and we're done with that, right? So because the set doesn't have duplicates, so if OD of K, so the minimum of this is less than the maximum of OD of S of I, then we can just add the difference character, which is S of I, plus K, which is a different character, plus the same thing. So like A, B, A, right? A, B, and then A. Otherwise, if it's the same character, then, for example, if we're seeing A, we have to say if OD of K, which is the same character, if the length of this is bigger than or equal to 2, then we know we have another 2. So if we're on A, we need another 2 A's to the right of it to satisfy. So index 1 and 4 in this case satisfy. So then we can just add S of I, AAA, plus S of I, plus S of I. And then at the end, if we print the set, we should see that the result is correct. So if OD of K and OD of S of I exist, change during iteration. Okay. Maybe we just do like this. Okay, cool. So I guess we don't even need this because that kind of messes things up a little more, but now you can see that we have ABA, AAA, and ACA. We have 4 here, and that's great because now we can just return the length of this set because we're not going to add BAB twice or BBB twice. We're just going to do it once. So output limit exceeded, just have to get rid of the print statements. And you still get time limit exceeded. That was another thing I ran into. Basically, min and max take O of n times. So what we're going to do is have a sorted list instead. And we're going to add so that the sorted list just keeps track of all the indices in order. So if you have B, it's just going to say 1, 2, 3 automatically. So then you know that the minimum is OD of K of 0 has to be less than the maximum, which is the last one, which is OD of S of I of -1. So that saves a bit of time. And in this case, it's almost there. 69. I didn't run into that the first time. So if it's equal to 2 or bigger than or equal to 2, oh man, okay. Oh, so length of scene can also, so if S of I so let's call this now as S of I plus S of I plus S of I, then we can just add now. I don't know if that's going to help. Okay, so time complexity O of n, but maybe we can just say if now is not in scene, then we increment our answer. And then we just return this. So if S of I plus K plus S of I is not in scene, then we increment our answer. Hopefully oh wow, okay, I guess not. I did not run into this the first time. Length of scene. it's one test case at the end that's kind of a pain. Maybe dot discard. Maybe that's better. Oh man. So maybe we just do this. If OD S of I, ODK, that's why I was deleting it here, because if not ODS of I, then we can just delete it and that saves time, right? ODS of I. So if OD of K and OD of S of I, but then you can't even do that because the dictionary was changed. Oh Lord, that's annoying. Oh. So I thought of something. Let's print OD. So if now is already in scene, then we continue because we don't want to process it again. And so AA is already in there. And there you go. That saves a tiny bit of time. Barely enough to give my own solution passing, but it falls in the bottom. But hey, I solved it at the end and I'm pretty proud of that. And yeah, that's it for this video. Just got to play around with it a little bit to optimize it. And thank you for watching and stay tuned for more.